Alright, this is the start of our Unit 9 Day 6 video. We're going to start this video off a little bit differently than ones we have in the past. And so the first part, and I'll remind you this again in just a moment, but you don't need to write a bunch of this down just yet. I just want you to watch and observe. This video is going to be a little bit different. Pay real close attention at the beginning. We're going to look at some interesting pieces as to how we get the volume formulas for pyramids and cones. And so we're going to examine this with a little bit different style of video. I'm not going to have you writing things down just yet. We're just watching the video, paying attention, and then at the end of the video is when we'll actually take a look at some of the notes. So first of all, I want you to remember this. The volume of a prism is equal to the base area, or area of the base of that prism, times the height. So if I had this prism, you'll see we would call this a pentagonal prism. The volume would be the area of one pentagon times the height of the prism. So here's what I want us to think about. What would the volume of a pyramid be of those same dimensions? Okay, where my pyramid is the same base size and shape and same height as the prism, but it's a pyramid instead of a prism. So we're going to look at that by answering this question. How many times can the pyramid fill the prism of those same dimensions? So we're going to illustrate that with some colored liquid that can best represent our volume. So I want you to take a guess here and write down on your notes how many times you think this amount will fill this amount. Alright, and let's see what we get. I'm going to try my best to fill this to the very top without overflowing. Okay, so there's one. Let's try it again, because we're not quite full yet. Ooh, got it real full that time. There's two, so it's more than two. And there's three, and actually that first one was a little bit less, and so it would actually have filled right up to there. So how many pyramids did it take to fill the prism? 3. And so we should be able to help understand what the volume formula for a pyramid is based on the volume of a prism. The prism was base area times height. It took 3 of these pyramids of the same base area and height of the prism to get that area. So the volume of a pyramid of those dimensions would be 1 of these out of a total 3, or 1/3 the base area times the height of your pyramid. Alright, the same kind of thing is going to work out with cones. Okay, but we want to test this out. I'm going to try and put this all back together and show you how it works for cylinders and cones. So let's take a look at cylinders, and remember that the volume of a cylinder is pi r squared, which would be the area of a base, times the height of the cylinder, the distance between those bases. Now, we want to then figure out what the volume of a cone would be with the same circular base and the same height. Okay, you can see those are the same. Alright, now for pyramids and cones in this lesson, notice we're just using actual height. I'm not using slant height like surface area did, because I'm not talking about the surface on the outside. I'm talking about how much space is taken up. So again, I'm going back to using the height measurement. Alright, so if I have one cone that is the same base area and height as its corresponding cylinder, we again want to ask ourselves this question. How many times can one cone fill the cylinder of the same dimensions? So let's try that. One, and this is going to be a little harder to pour. 2. Again, trying to be careful. And let's see if a third one will top it off. Right up to the top. So again, we had 3 cones that filled up one cylinder as long as they have the same dimensions, same base area, same height. So if it took 3 of these to fill this, that means this volume, the amount of liquid or amount of substance that would fit in one of these, has to be 1 out of 3 total that fill this shape. So once again, how many times can we fill it? 3. That means that our volume of a cone formula is 1/3 the volume of the cylinder, pi r squared h. Remember, we're talking about the actual height from the top down to the bottom, or if you're talking about it this way, from the top down to the bottom. All right, the next part of the notes, we'll actually take a look at using those formulas to solve some problems. Okay, so now you should be able to understand where we get the formulas for volume of pyramids and cones. Hopefully that demonstration helped you understand that a little bit better. And so we do want to start with examples involving pyramids. All right, we have that formula again. The volume of a pyramid is always 1/3 of the base area times the height. Okay, and the height is not slant height like it was in surface area. The height is the actual vertical distance from this peak of the pyramid to the base. All right, and so we're just going to apply that to some examples. All right, so we're going to use our formula, making sure we do 1/3. Now 1/3 is the same as dividing by 3. So writing it this way is the same as writing it as base area times height all over 3. And a lot of times this is how I will write that. All right. So capital B stands for the area of the base. This base of this pyramid is a rectangle. It's 10 by 11. Okay, if I wanted to do that separately, I could. Okay, or I could plug this directly into the formula. But either way, if I did 10 times 11, that's 110 for the capital, or for the area of the base. The height of the pyramid here is 16, and that's all divided by 3. Okay, so we do that calculation. We do get some different decimals this time because we're dividing by 3. And so in this case, we get 586.67, okay, when we round it, cubic inches. Okay? All right. So let's jump down. We're going to skip number 2. All right. We're going to do number 3. Now, this is different because they give you slant height. I don't want that for my height of my pyramid. I want the actual height. All right, so I'm going to kind of draw in what the actual height would be, all right, to the center of your rectangle. And it forms a right triangle, which kind of looks like this. Okay, if I could cut it out and show you, this would be 25. That's the slant height of the pyramid. This is what I'm looking for. And then this segment here, from this point to the center of your rectangle, is half this side, because this is a square. So it's half of 14, which is 7. So the first thing I need to do is find height using Pythagorean theorem. Okay, step 1 is going to be to do 7 squared plus h squared equals 25 squared. Okay, so we're going to do our calculations here. Okay, then we subtract 49 from both sides. And h squared is 576. Then we take the square root of that. And we get that h is 24. All right. So the height of your pyramid is 24. So the volume is 1/3. The base area, okay, base area here is 14 times 14, or 14 squared, which is 196. So we're going to take that 196 times the height of 24 and divide all that by 3. And that gives us a volume of this pyramid of 1,568 cubic feet. So that's how you find volume of a pyramid. Now, if the base of your pyramid is a triangle, okay, you need to remember the base area formula for triangles would be 1/2 base edge times height, where this height is that. Okay, we'll call it height of a triangle, put a little triangle after the H. The height of your pyramid, HP, is this. So we don't want to plug this in here for the base area. All right, and I'm not going to work the entire thing out. Okay. All right, let's move on and take a look at some cones. Let's turn the page. Okay, same idea. We're just going to find the base area times height divided by 3, or 1/3 of that. Now, this pi r squared is equal to the area of a circle. Okay, so pi r squared is the area of that circular base. So all we have to do is plug in the information. Volume is 1/3 pi times the radius of 9 squared times the height of your cone, which is 17. Okay. So we're going to do our calculations. I'm going to leave the 1/3 there for now. 9 squared is 81. And then 81 times 17 is 1,377. So I have 1/3 of that. When I divide that by 3, I get 459 pi. And then I can multiply those, multiply 459 times pi, and I get about 1,441.99 cubic yards. Okay? All right, I would like for you guys to try number 8 on your own. Pause the video to give yourself time to do these calculations. What I want you to realize is if the diameter is 5, you need to find the radius first. Okay, remember, divide that by 2. So find your volume of this cone, making the height of your cone 8 inches. All right, if you need any more time, pause the video. Otherwise, this is what you should get. All right, 52.36 cubic inches. Okay, and so here's what we're going to do. I want you to try and do number 9, 10, and 11 on your own before coming to class, and then we will probably do. I don't know why there's 2 number 11s. It's just a typo. It should be a 12. Okay. Try and do these on your own, come up with the answers before coming to class, or at least get some equations written down, and then we'll try and finish these notes out in class. But that does include the examples, we're going to cover in the video.